Okay, carry on talking about the way electrons are arranged in atoms. Well, we're okay with this idea now, hopefully, that electrons aren't point charges, but they can they are negative charge cloud, and that negative charge cloud is only allowed to occupy certain spaces called orbitals, certain shapes. Okay. Right, the first orbital, which is closest to the nucleus, as we've seen before, is 1s, yeah, and you've got room for 2 electrons in there. So if we look at hydrogen, yeah, that's going to have 1 electron. So here's hydrogen here, it's going to have 1 electron in 1s, yeah. So, right, helium, next one here, where you're allowed to fit 2 electrons in the same orbital, so that will also have that have 2 electrons in 1s, so we'll have 1s2. Now, when you get to lithium, that's full up, the third electron has to go into this one here, doesn't it? Into the 2s orbital, which is spherical again, but slightly bigger than the 1s. So lithium is going to have, the last electron will be in 2s. Beryllium has 1 electron more, that can pair up with the one that's in there already with an opposite spin, and that's going to be 2s2. Now, when we get to boron, we now can see that our 2s is full up. And so what happens is we have to start filling up the next orbital available, which is 2p. Okay, now 2p is more complicated than 2s. I've drawn it here. All right, you can see it's about the same. The electron is about the same distance from the nucleus all the time. But can you see I've drawn 3 axes there? I've drawn x, y, and z. And that's because there's three of these p orbitals, and they're all at right angles to each other. You can see there we have the x, one at right angles to that, the y, and one at right angles to that is the z. And of course, I've drawn them separately so you can see where they are, but of course they're all going to be superimposed on each other. The drawing would look a bit of a mess. Okay, so let's see what happens with when those electrons are filled up in 2p, how they're filled up. Okay, so we're going to go to boron. Yeah. Now, boron, what will happen with boron is that you will get 1 electron will go into one of those orbitals, okay? Say you go to 2px. So we write that down as 2p1. Now carbon has got 2 electrons. It's got 1 more electron that's got to go in 2p. But it won't go in the 2px and pair up with it. It prefers to stay away from it if possible, and it goes in another p orbital, one at right angles. So I would write down 2p2 there. I'm going to write it down, but it's a bit misleading. It shows you that one's in 1p orbital, the px, and the next one is in the py. Let's go to nitrogen. Okay, that's got 1 more electron than carbon, so that's got 3 electrons got to fit in the p orbitals. And so I'll write 2p3 there. That's and again, like the carbon, they won't pair up in the same orbital if they can avoid it. So you'll get in nitrogen, you're going to get 1 electron in the 2px, 1 in the y, and 1 in the z. Then we come to oxygen, 1 more electron, so that's going to be 2p4. Now the electrons have got no alternative now but to pair up, have they? So with oxygen, you will get 2 electrons in 2px, you get 1 in the 2py, and 1 in the 2pz. Come on to fluorine, again, they've got to pair up, so fluorine, you're going to get, here we go, fluorine, that's going to be 2p5. You get 2 in 2px, 2 in 2py, and 2 in 2pz. Sorry, 1 in 2pz. Yeah. Finally, neon, that's going to be 2p6, so you will have 2 electrons in each p orbital, each one with an opposite spin there, won't you? That's what will happen. Okay, now before we move on to what happens to sodium, which you can probably see what's happening there from the way I've drawn it, let's draw one of those energy level diagrams and just start filling in the, so this is potential energy. It's got more potential energy because the negative charge is further away from the positive nucleus down here. Okay, so I'm going to draw. We've got the 1p orbital there. We've got 2p there. Sorry, 1p, 1s, I beg your pardon. You can have 2s there. And then not much higher energy than that, very close energy really, but just a little bit higher. You've got 3 2p orbitals. You know, you can have that one as the X if you like, that one is the Y, and that one is the Z. And they've all got the same energy. Okay, so let's see how they start filling up. Right, so let's think about beryllium, yeah? Beryllium has got 1s, it's got 2 electrons in 1s and 2 in 2s with opposite spins. Then we go to boron. Well, we draw that like that, will be boron. Okay, now the electrons won't pair up unless they've got to. So for the next atom along carbon, that electron goes in 2py. Sometimes they say they've got parallel spins. And for nitrogen, they won't pair up still because they don't have to. That will the extra electron will go in 2pz. But when you get to oxygen, then they do have to start pairing. It's got one more electron, and it's got to go there. There's fluorine, and that would be neon there. Which brings us to sodium, doesn't it? Okay, which is there. Now, sodium 2p is full up, so where does it go? The electron goes in this one here, which is 3s, which is very similar shape to 2s, but it's further away. Magnesium, you're going to get 2 electrons, okay, in 3s. And then once the 3s is full up, then these elements, aluminium, silicon, phosphorus, and so on, they have to start filling up the p orbitals, and they'll fill them up in the same way as we filled up the 2p. So you'll get 1 electron in there. When you've got silicon, which has got 2 electrons in 3p. Sorry, that's should be say 3p down there. Yeah, these are 3p. With silicon, so the electrons will not pair up. If they don't have to, they'll go in separate p orbitals until all the p orbital is filled up, okay, which will take us to argon. And then we come to potassium, the next element, and then you have to start filling up 4s. Okay, I'll just show you where 3p is on this diagram. It's not really to scale. 3p is the gap between 1s and 2s is big. The gap between 2s and 3s isn't quite as big. There's 3s, and with 3p, very similar energy to 3s, but there's 3 of them, the X, the Y, and the Z. Okay, so if we look at the electron, right, if you look at the electronic structures there, I don't know what happened then. I've got them down here. Okay, so there they are. Right. Okay, so what I've done here is in blue, I've done the old GCSE way of saying, 1 in the first, 2, 4, 2, 5, whatever. And hopefully you can see here, let's take nitrogen as an example. Let's look at nitrogen. Yeah, the old way of doing it was 2, 5, and the new way we're saying is 1s2, 2s2, 2p3. And as you can see, really, you say this is, you've got 2 in the first shell, and you've got 5 in the second shell. The only difference is we call this the second shell, but we'd say the S and the P, we'd call them subshells. Okay, they are subshells. So we divide, if you like, the second shell into the S orbital and the P orbital. Okay, I think we'll leave that one there.